You can type out the basic foundation of the Python programming language in exactly 60 seconds. Let's start the clock. First, the print command. You type print, add a message, and the computer instantly outputs that exact text onto your screen. Next, a variable. By typing name equals Alex, you create a dedicated storage space in the computer's memory to hold that specific piece of data. Python also has a calculator built right in. You use basic math symbols, like a plus sign, to add numbers together instantly. Then we add an if statement. This creates a strict rule, forcing the computer to make a decision based on the data it receives. Finally, a for loop. This takes a single action and tells the computer to rapidly repeat it over and over again. That's it. Time. Those 5 commands are the basic tools used to build almost every program you use today. Okay, let's hit pause. That was a lot of new rules and symbols flying at you all at once. To actually learn how to code, just memorizing the way those lines are written won't help you much. You need to understand the real-world logic driving them. So let's unpack exactly what just happened. Let's look back at that line, name equals Alex. Think of a computer's memory as a massive, completely empty house that needs to be organized. This diagram shows how variables solve that problem. A variable is a moving box. Assign Alex to name, data drops inside, and you label it. The print command asks the computer to find the box, open it, and read it. Without these labeled boxes, raw data would be lost in the void of the computer's memory. Variables give that data clear context so you can locate it instantly whenever you need it. Math in Python follows that same logic. Doing calculations is taking the contents of 2 or more of those moving boxes and combining them together. But code gets interesting when we introduce the if statement. This is the program's primary decision maker. This illustrates an if statement acting like a bouncer. It checks a box's label against a rule. 20 passes the greater than 18 test. The door glows green. Code proceeds. If it fails holding 16, the else condition turns the bouncer red, redirecting the code. Conditional statements take a static list of text and transform it into a smart system. The program is now capable of reacting to new information. Finally, we have the for loop, the solution for repetitive tasks. If you wanted a character to take 5 steps, typing take a step 5 separate times is a very slow way to work. This animation shows a loop in action. A loop acts as a multiplier. You write the task once, wrap a bracket around it, and tell the computer exactly how many times to execute it. Humans get bored and make mistakes when repeating the same chore. Loops leverage a computer's greatest advantage, executing boring, repetitive work perfectly every time, in a fraction of a second. All 5 commands combine into a single script. The logic connects. The boxes flow through the bouncer and into the multiplier. Reading top-down, you store a name, check an age, and if they pass, print their name 5 times. This is Python's greatest strength. The code is intentionally built to mimic plain English, rather than the complex internal language of the machine. And because Python is free for anyone to download and use, you don't need any expensive professional software. You can begin writing real scripts directly in your web browser today. You now understand the logic used to create your favorite apps. You've moved past just looking at a screen. You see how it's